A warm welcome to all. In this lecture, we are going to see about how to design the CMOS circuit. In previous lecture, we have seen what is CMOS circuit and how it is designed, and we have seen the design of CMOS inverter and its working. Basically, CMOS circuit consists of pull-up network and pull-down network. Pull-up network is always PMOS and pull-down network is always NMOS. So brief lecture of this is we have seen in previous lecture. Now, as PMOS is used in pull-up network, NMOS is used in pull-down network. So CMOS is a combination of PMOS and NMOS circuit. We have four basic conditions for designing the CMOS circuit. First condition is when the Boolean expression is in multiplication format, PMOS is used in parallel connection and NMOS is used in series connection. And when the Boolean expression is given in addition format, PMOS is used in series connection and NMOS is used in parallel connection. So these are the four basic connection. For PMOS multiplication expression, it is connected in parallel, and NMOS it is connected in series. For addition, PMOS is connected in series, NMOS is connected in parallel. Now in this lecture, we are going to see how to design the CMOS circuit for logic gates. For example, first we are going to design for NAND gate. The Boolean expression for NAND gate is Z is equal to A dot B whole bar. CMOS is complementary metal oxide semiconductor. As the name implies, it is a complementary circuit. So it is easy for us to design CMOS circuit for complementary gates such as NAND, NOR. For designing and OR gate, we need to attach inverter at the output of the circuit. For example, for designing AND gate, with this circuit, we need to design CMOS inverter at output of the NAND gate. Now let us see how to design the NAND gate using CMOS transistor. First, as PMOS is always used as pull-up network, NMOS is always used as pull-down network, we have two inputs A and B. So we need two transistors. For PMOS we need two transistors, for NMOS we need two transistors. So one transistor is input A, another transistor is input B. Same for NMOS, one transistor is input A, another transistor is input B. So now we are going to see how to design or how to connect. First, for NAND gate, A dot B, it is in multiplication format. A dot B means multiplication. So we have two input A and B in multiplication format. For multiplication format, for PMOS, we need to connect the transistor in parallel connection. So A and B are connected in parallel. A and B are connected in parallel for PMOS, and for multiplication NMOS, it must be connected in series. So NMOS transistor A and B are connected in series. At the middle of its connection, we can get the output. We always derive output at its middle. So same for designing AND gate, we need to add inverter at its output. Circuit for AND gate. We have two inputs A and B. Z is equal to A dot B. So we need two transistors for PMOS, A and B. As it is a multiplication function, PMOS is connected in parallel combination. Same for NMOS. As it is multiply, NMOS is connected in series combination. So at the middle we derive output. This is the circuit for NAND gate. For designing AND gate, we need to attach inverter at its output. So PMOS inverter normally consists of single PMOS and single NMOS. we have seen its working in previous lecture. So final output is derived at its middle connection. Here we get the output of AND gate. That is, here we get a final output of A dot B. Here at this point we get a output of NAND gate. That is A dot B whole bar. As CMOS is complementary circuit, we first output we get for complementary gate, and by adding inverter we get the output of AND gate. Now let us see how this NAND gate works. First, when we are giving input A 0 and input B 0, same for NMOS, input A is 0, input B is 0. This is the truth table of NAND gate. When input A and B are 0, output is 1, 0, 1, output is 1, 1, 0, output is 1. For 1, 1, output is 0. So now let us see the connection, the working, how it works for 0, 0 and 1, 1. Now when we are giving input as 0 for A and when we are giving input as 0 for B, normally PMOS transistor gets on when we give input 0 and NMOS transistor gets on when we get input 1. This is the condition of PMOS and NMOS. So this is PMOS, this is NMOS. We are giving input as 0. So when we are giving input as 0, PMOS gets on. When we are giving input 0, PMOS gets on. When we are giving input N, input 0, NMOS always gets on when input is equal to 1, but here the input of NMOS is 0. So when we are giving input 0 for NMOS, it gets off. That is, it is open circuited. Off condition is open circuited, on condition is short circuit. Short circuit is nothing but it will pass the signal when the circuit is shorted. So it will pass the signal. It will pass the signal for short circuit. When the circuit is open, that is in off condition, so it will be like this. So now the circuit is open, it will not pass the signal. So when input is 0, PMOS gets on. Here also PMOS gets on. When input is 0, this NMOS gets off. When the input is 0, this NMOS also gets off, and it is open circuited. Here also it is open and here it is short. So when it is short, it will pass this VDD. So it is short, it will pass this VDD. Here also it is short, it will pass the same VDD. So as VDD is always I, for example VDD is 1 and ground is 0. So it is short, both the transistor are short. It will pass this VDD to the output. As VDD is 1, we will get output as 1. As it is open, it will not pass any signals through this. It is open, so it will not pass this ground, so we will get output as 1. When the input is 0, 0, the output will be 1. Same when the input is 1, 1. When A and B 1, 1, we need to get the output as 0. So this is the circuit for NAND gate. PMOS is connected to VDD pull-up network. NMOS is connected to ground pull-down network. For multiplication, NMOS is connected in series. When the input is 1, 1, we get output as 0. So here we have given input as 1 for A and input as 1 for B. Normally PMOS gets on when input is 0. Here we are giving 1, so PMOS gets off. Here also PMOS gets off and NMOS gets on as input is 1 and NMOS get on. So at the middle of its connection, we derive its output. When it is off, it is open circuited. It will not pass, this pull up network will not pass any signal. Will not pass signal. So pull down network is on, off. So it is on, it will pass the signal. So it is on, this short circuited, this is short circuited, and this transistor is also short circuited. So as ground is 0, it will pass the 0 to the output. We get a final output as 0. So when the input is 1 1, we get output as 0. So when the input is 0 0, we get output as 1. Similarly, when the input is 0 1, we get output as 1. So when input A is 0, PMOS gets on, and when input B is 1, PMOS gets off. Here for NMOS, when the input A is 0, it gets off, and B is 1, so this transistor gets on. As A transistor of NMOS is off, it is open circuited. So this is short circuited. This transistor will pass ground 0, so it will pass ground 0 to the above transistor, but the above transistor is open, so it will not pass any signal. This 0 will get stuck here itself. And now in pull-up network, this transistor is on and this transistor is off. That is, this transistor is short circuited and this transistor is open circuited. The basic difference is PMOS is connected in parallel circuit. Wait, now go to. In previous, we have seen for 2 input combination, for 0 0 we got output 1, and for 1 1 we got output 0. Now we are going to see for different input combination, that is for 0 1 and 1 0. When input is 0 1, we get output as 1. So when we are giving input as 0 for A and input as 1 for B, this PMOS gets on. As I said previously, PMOS always gets on when the input is 0 and NMOS always gets on when the input is 1. So this PMOS gets on, this PMOS gets off, this NMOS gets off, and this NMOS transistor gets on. As PMOS is connected in parallel combination and NMOS is connected in series combination, there will be some difference in this NMOS transistor for passing signal. We will see that this NMOS transistor is off, so it is open circuited. This NMOS transistor is on, so this NMOS is short circuited. As this is short circuited, this NMOS transistor will pass ground to the above transistor. So it will pass 0 ground to the above transistor, but the above transistor, that is input A transistor, is open circuited, so it will not pass any signal, so it will not give any output. We cannot derive output from this pull down network because it is in series connection. So it is the below B transistor is short circuited. It will pass 0 to the above transistor, but it is open, so it will not give any output. Now in pull up network, this A transistor is on and this B transistor is off. So this A transistor is short circuited and this B transistor is open circuited. So VDD, that is 1, will pass through this A circuit, A transistor. So this 1 will pass through this A transistor to the output. Here it is in parallel connection. The difference is pull down network is in series connection and pull up network in parallel is in parallel connection. So there is no link between A and B. This VDD will directly pass to the output. B transistor is open circuited. It will not pass this 1 to the output. So as this is on, this transistor will pass 1 to the output. So the final output we will get as 1. So for 0 1 combination we got output as 1. Then 1 0 combination, when input is 1 and 0, this PMOS gets off, this PMOS gets on, this NMOS gets on, and this NMOS gets off. So it is open circuited, it is short circuited, it is short circuited, it is open circuited. As it is open circuited, it will not pass signal. So it is short circuited, it will pass signal, but as this is open, below transistor is open, it cannot pass this ground. So as it is short circuited, it will pass, but the below open circuit transistor, it does not pass ground to the above transistor, so there will be no signal here. So this pull down network will not pass any signal. We cannot derive any output from the pull down network. In pull up network, this is open circuited and this is short circuited. So VDD will pass through this transistor to the output. So the final output will be 1. So for 1 0 combination we got output 1. We have seen working of all these 4 combination for NAND gate. This is the design of NAND gate using CMOS logic, and we have seen its working. Thank you.